about this before. So we want to expand this for 4 terms, right? What is this one really similar to? What's this one really similar to?
1 over 1 minus y.
Yeah, 1 over 1 minus y. What does that equal? I don't want to restart now. Go away. 1 over what? Yeah, it's the really nice one, right?
Yeah.
So we know therefore that 1 over 1 minus ln of 1 plus t, what's that going to equal? 1 plus what? Yeah. What? ln of 1 plus t plus what? ln of 1 plus t what? Squared plus ln of 1 plus t. Now you might be tempted to say you're done at this point. Are you done? Why? Can someone tell me clearly why you're not done?
You do each value.
What's on the left and what's on the right? There's an ln on both sides. We want to get rid of that ln, right? Well, what does ln of 1 plus t equal? Can someone tell me what that is equal to? You've seen it before. Nam, what is it?
That's 1 plus t.
Yep.
Minus t squared.
Oh, minus. Yep. Minus what?
T squared over 2.
T squared over 2. Yep.
Plus t cubed over 3.
Yep. It goes on, right?
There's no 1.
There's no 1, I think, right? There's no 1?
Yeah.
Oh yeah, there's no 1.
There's no 1. Oh, so it's fine. It's fine. And it alternates sign, right? So where do you take this? Where does this go? Yes, and guess what, kids? You still have to do, sometimes you have to do hard algebra. We've done it before. You got to do it again. You got to clean it up. How many terms is this thing asking for?
4.
The first 4 terms. So you're not going to have to multiply out a totally terrible number, but you know that this is therefore going to equal 1 plus t minus t squared over 2 plus t cubed over 3 goes on like that, right? That's the first one. And then where does that go? Where do you plug it in? Where else do you plug it in? Yeah, so it's going to be this thing what? Plus this thing squared. And then what is it? Plus the same thing cubed. No, it's plus. It's plus the same thing cubed. So now you just have to do algebra, everybody. I know you're not going to like it that much. I know. I got it. It's okay. It happens. It happens. So this thing is cubed. Are you with me so far? Okay. So you have to clean this up and be real careful about it. So first you ask yourself, are there any other constants besides 1? No. What about just t? There's just that one t, right? So now, though, you have to ask yourself how many t squareds are there. So there's this one, right? Minus t squared over 2. But you also have to do out this one right here. You have to square this one to get another t squared term, right? Everybody sees that one?
Yeah.
So what are you going to get out of this one? When you multiply this out, you end up with t squared. Will you end up with any other t squareds?
No.
There'll just be that one t squared. So then you have plus t squared. Are there any t squareds in this one? No. So we found how many? We found the first 3 terms. We have 1 plus t plus what? T squared over 2. Do you agree with that? These 2 terms right here combine to become t squared over 2. So we have 3 terms. Now you have to find all the cubes, right? Collect them carefully. Here's one of them, right? There's going to be one in here. There's going to be one in the second piece. Yeah, there is. Yeah, there is, because look, t minus t squared over 2 plus t cubed over 3, right? Times t minus t squared over 2 plus t cubed over 3. Where are you going to get it? You're going to get it from there and from those, right? So how many of those are you going to have? You're going to have two of what? Negative t cubed over 2. Do you see that, everybody? Does everybody see that?
Yes.
It's really important. So that is one of them, but is there going to be yet another? Yeah, there's going to be a t cubed from this one. So how many do you have? You have that t cubed, and then you have... Careful here. What happens?
Cancels.
Does it cancel?
No, wait.
Hey, hold on. You have to be really careful here.
2 times t cubed over 2.
113.
Oh, I know.
You have to be really, really careful here. So first of all, is this accurate right there? Do we agree with that? So look, there's a t cubed here from there, right? What happens to these two? They cancel each other out. So what are you left with? plus t cubed over 3. So your final answer would be that right there. You have to collect terms really carefully. Really carefully. Do you sense a pattern developing? Do you sense a pattern?
Yes.
Yeah, it's kind of cool. We sense a pattern. Proving it's another thing, but it's not that bad. Okay, so you also wanted to do what expansion. So what's the first thing you have to do? Expand them. That's the first thing you have to do. So what's ln of 1 plus x? What's that equal? What's ln of 1 plus x? I just asked you about this. What is it, Annie?
X
Yep.
minus x squared over 2.
Is it minus or what?
Oh, no, I started with plus x squared over 2.
Yep. Then
It's minus.
I was just is it minus or plus?
Minus x squared
Then what?
plus x cubed over 3.
3 minus what?
X4 over 4.
X to the 4 over 4, and it keeps going, right?
Yeah.
So therefore, what is ln of 1 plus y squared going to be? Y squared minus y to the 4th over 2 plus y to the 6th over 3 minus y to the 8th over 4. Do you agree with that?
Yeah.
So we've done this one, right? We good? What about sine of x? What does sine of x equal?
X
Yep.
minus x to the, oh, no. Oh, yeah, no, it's x
Over what?
over 3 factorial
Yep, plus
plus x to the 5th over 5.
minus x to the...
7 over 6.
We good with that so far? So what does sine of y squared equal? Y squared minus what? 6 over 6 plus y to the 10th over 10 minus y to the what?
14.
Yeah, over 7 factorial. It's 5 factorial, sorry. I want to keep these in factorial form. 3 factorial. Are we okay, everybody? I hear some chatting. Are we okay?
Yeah.
We good? So therefore we've done the second one. Yay! So now we just have the third one to do. What's the best way to write this one? Well, what's cosine of y equal to? 1, yep.
X squared, x squared.
One at a time. Ian, go.
X squared over
Is it plus or minus?
minus.
X squared over 2
Yeah.
factorial plus x cubed over... Oh, it's y, right? Thank you.
And it's y to the 4.
Did I cut something off?
No, so y squared.
Over...
No.
Oh, y to the 4th?
Yeah, but the first.
Yep. Over what?
4.
Thank you. Minus y to the... Over 6 factorial. It goes on like that for a while, right? But that's not what it's asking you for. It's asking you for... Okay, so then what are you doing? You're doing 1 minus what? That thing, right? So therefore, what is 1 minus cosine y going to be equal to?
Inverse.
Y squared over 2 factorial minus what? Over 4 factorial plus what?
Y to the 6.
Over 6 factorial, right? So it's asking you to put these in what? In increasing order. So what are we looking at here? We're looking at this, we're looking at this, and we're looking at this. Are they similar? Yeah, what do they share? They share, hey, that's the same in both, right? Oh wait, is it the same in both, all of them?
No.
Is it almost the same?
Almost.
So how are we going to compare these? Any ideas? Terms, I like that idea. How do the leading terms compare? How does this compare to this, compare to this?
1 minus cosine y is the smallest.
Yeah, so therefore, 1 minus cosine y is going to be the smallest, but then you need to compare the next one. Anything, how do you compare these two right here? How do they compare?
Well, the denominator.
All the numerators are the same. The numerators get really, really small here, right? And these are bigger, right? So which one of these two, which one's going to be bigger? ln 1 plus y squared or sine of y squared?
The numerator is bigger, not smaller.
Well, near zero.
Okay.
So sine of y squared is going to be? You have to be really careful here, everybody. Take a look at this. Exactly. So the next one is ln of 1 plus y squared, and then it's sine of y squared. That's a really cool question. I like that one a lot. I think you got it. Okay. So first of all, we're using this function, right? Correct? We're using that function. So to get 0.5 to the 1/3, there's another thing we need. What's the x value going to be? Yeah, it happens to be the same as what you plug in. Is that always the case? No, it just happens that we want the base of the exponent to be a half. 1 minus what is a half? A half. It just happens to be the same number. Is everybody with me so far? It just happens to be the same. It doesn't have to be the same number. So what do? We're going to use that formula, that thing, right? The error, E3, right? Is going to be less than or equal to m over what? Yeah, what is n? So 4 factorial, x minus what? 0 to the what power? To the 4. What value are we plugging in for x? So what do we have here? M over 4 factorial times what? 1/2 to the 4th. Remember that the entire core of Lagrange error bounds is a search for what? A search for m. So we're searching for m, and we know that m has to be greater than or equal to, what derivative are we going to now? The 4th, right? On what interval? On what interval? I would go from 0 to a half. It has to include the value. So go to 0 to a half. So we have to find the what derivative? Yeah, this is where the algebra gets a little annoying. I understand that. What's the first derivative of this? Any? What's the first derivative?
1 over 3.
Yep.
1 minus x.
To the?
-1.
Nope. To the negative what?
Oh, -2 over 3.
Times what?
-1.
Times -1, right? And that's a -1, right?
Yeah, -1.
I'm not going to simplify any of these yet. What's f double prime of x going to be? 1/3 times -2 over 3 times 1 minus x to the negative what? 5 over 3 times -1 squared, because it kicks out a -1 again because of the chain rule. F triple prime. What's that going to be, Chip? 1/3 times what?
Negative
2/3 times
-5
times
x
1 minus x to the
x to the -7
times -1 to the
cubed.
cubed. Oh, finally we get to 4th here, right? And what do we end up with? Negative what? 8, not 7. Thank you. I can almost subtract. No, it's my fault too. -2 over 3, -5 over 3, -8 over 3, 1 minus x to the -11 over 3, and -1 to the 4th. So what happens? That's gone because it's positive, right? And what does this simplify to? I think it's what? What do you get? 80, -80 over what? 81, 1 minus x to that, right? So we're trying to find out where is that, what's a value that's the biggest it can be on what interval? 0 to what? 1/2. How do you do that? You've done that many times in AB calculus. How do you find the largest value on an interval? How do you find it? Yes, exactly. You're going to use a derivative to find what? What points are you looking for? Critical points. You also test on an interval. You test to see if there's critical points, and you test the end points. So if this is F4 right here, what do we need to find? So we're looking for critical points. Looking for critical points. So we need to take F5 here. So what do you end up with? F5 of x will equal what? -80 over 81 times -11 over 3, 1 minus x to the what? Times what? Well, it's just -1 now. It was -1 to the 5th, so it's just -1. So we end up with what? We end up with -80 times 11 over 81 times 3, right? And if we're finding critical points, what do we set this equal to? We set this equal to what? 0. The only way to make that 0 would be 1 minus x to the -14 over 3 to be 0, correct? What does negative power mean, everybody? 1 over 1 minus x to the 14 over 3, right? Is that possible? Is that possible? Can you make a fraction equal 0 if the numerator is always 1? No. So no critical values, right? That means the function either just increases or decreases. Just increases or decreases. So what do you have to test, Annie? You have to test the endpoints. The endpoints. And you test the endpoints of the function. This is the function we want to know what the maximum is of, right? So what do we plug into that function? We plug in two different things. When what? When x is 0 or when x is what? 1/2. So when x is 0, what do you get? F4 at 0 is negative 80 over what? 81 times 1 to the, which is what? Well, negative 80 over 81, right? Do you agree with that? Okay, what about F4 at 1/2? What's that going to be? Negative 80 over 81 times 1/2 to the negative 11 over 3? 1/2 is 2 to what power? 1/2 is 2 to what power? To the negative 1 power, right? So how can I rewrite this? Negative 80 over 81 times 2 to the what power? 11 over 3. Now here's the thing. Remember, this is what we're doing. F4 on that interval has to be less than or equal to m, correct? What do you see around the function, the fourth derivative? What do you see around it? What do you see here? What are those, kids? Absolute value. So what do you do to both of these? Which one's bigger? The second one. Which one's bigger? The second one is bigger, right? So what's our m value going to be? What's our m value going to be? Not 80, because absolute value is around it. So what's it going to be? 80 over 81 times 2 to the what? So where do we take this? Where does that go? So we know m is now what? 80 over 81 times 2 to the 11 over 3. Right there. It's not pretty.
And we have to take
I know, it's not cool. It's not cool. But the point is, it asks this. What is, it says, let's just go back and see what it says. It says times 2 to the 11 over 3 all over 4 factorial times what? 1/2 to the 4th. Now, yes, could you spend some time simplifying this? Yes. Is that the bound? Yes. Could you plug that into your calculator and get some decimal? Absolutely. But is that right there the bound? Yes, it is. Why would you need your calculator to figure out the decimal equivalent for this? What's the one thing in there that forces you to use a calculator to find a decimal equivalent? What part of 11 over 3 don't you like? The cube root, right? It's not a nice one. Yeah, go ahead.
We are approximating like something to 1/3 power.
How could you do to this? If you wanted to make this, you can only make it bigger. How could you make it a little bigger, but make it so that you could actually do it out without doing cube root? What one number could you change? You don't like the 3, right?
Yeah.
So what should you change? Not the 3.
To the 2.
Change the 11 to what?
12.
Change it to 12, right? It's going to make it a little bigger, right? A little bigger, but all of a sudden it's 2 to the 4th power. This turns into 16. Can you cancel all this down? So do you understand the point right there? So you can massage it a little bit. The whole point is try to get an estimate that doesn't involve the original function. Because if we can do this, what could we do at the beginning? Just find the cube root originally. The whole point is to deconstruct it so that you don't use the original function. Ian, yes?
Where does the f of x minus...
Like, if you wanted to do it, you could change it into, you know it's going to be less than what? You could change it, and you could do it out, but I'm saying, once again, you do not need to if this was part of the test. You would say, unless you are forced to, 80 over 81 times 16 over 24, 2 to 16 right there, like this. You see that? It's just 16, sorry. It's just 16, sorry. So what cancels? So yeah, you can cancel this. You remember there are questions where you will be forced to simplify, like on the AP exam, they might say, show that it's less than some fraction. You're going to have to massage it. Do you remember those comparison tests we did at the beginning? It's very similar, right? You can only make it bigger, but you want the best lower bound, the least upper bound. So you don't want to get careless. You don't want to make it too big. Change it just a little tiny bit. Put everything away except the pencil. Does this look familiar right here? Does that expression look familiar? What is that?
Looks like the error.
That's just what? That is what? That is error. That's E4, right? That is E4. So you're trying to show that the error is less than 1 over 3,000. Do we have an expression for E4? we know from all of the work we've done that E4 has to be less than or equal to what? M over, yeah, it's going to be n plus 1 factorial x minus a to the n plus 1, correct? In this case, n was what?
4.
It was 4, and a was going to be 0. It's centered around 0. So we know that E4, the absolute value of E4 is going to be less than or equal to m over, not n, it's now what?
5.
Yeah, 5 factorial x to the what? X to the 5. So what are we doing here? Also, what number are we plugging in? What are we evaluating it at?
0.
Nope.
1/4.
1/4. It's around 0, but we're evaluating it 1/4. So x equals what? X does indeed equal 1/4. So we now know, just write it out, takes 2 seconds, m over, what is it, 120? 1/4 to the what? 5th. But now we need to search for what? We need to search for m. And we know, because n is 4, we're looking, when is f5? We need that, correct? On what interval? Well, around what? It's centered around 0. So they gave us right here a graph of f5, the absolute value of it, right? So around 0, where's 1/4 on this? Well, 1 is here and negative 1 is there. So where's 1/4? It's like one tick mark, right? So at that, so if we said around 0, right? It needs to go to at least where? At least what? 1/4. What we're plugging in, x, exactly, right? Can you tell me at this value, at x equals 1/4, what's definitely bigger than the output? 40 is definitely bigger than the output. Do you agree? So what should we let m equal?
40.
Yeah, so let m equal 40. Where do we plug that in? Up there, correct? So now you got to do a little bit of math here, and what are you going to get? 40 over 120, 1 over 4 to the 5th, right? Well, what cancels there? You end up with 1/3 times 1 over 1/3 over 4 to the 5th, right? So you're going to have to do out 4 to the 5th. What's 4 to the 4th? Do you remember? Careful. 256. And then we multiply that by what? 24, 22. What do you get? Oh, 1024. Oh, we should know that. Maybe. Due to power features, we're not done. We're not done yet, right? So what does this equal? 1 over 3 times 1 over what? 1024? What does that equal? 1 over 3000 what? Oh, look, we just showed that the maximum error has to be less than 1 over 3072. Does that suffice this?
Yes.
It sure does. The whole key to this question, this is less a math question and more, to me, a reading comprehension question. All the information is in front of you. So when you get a question like this is directly from an AP exam. When it's written that nicely, it's from an AP exam. And you don't have a calculator, is that a really good feeling? It should be, because it means all the information is going to be right there in front of you. Also, if it's not a calculator question, you're not obsessing. Is this 35? No. You go to the first thing it gives you that's definitely bigger, because what do you see right here? You see a gap, right?
Yeah.
There's a gap. So you know 40 is bigger than what f5 of 1/4 is. Okay, you can sit down.